Hi, we're still doing absolute value, and in this case, I'm asking you, or the problem asks, to find the total area, and the keyword here is total, of f of x equal to negative x squared plus 6x minus 5 from 0 to 6. Okay, so that means we're going to integrate from 0 to 6. So we're looking at total area, what we're going to do is do absolute value. So one note here, that when you're asked for total area, you're going to integrate from f of b of the absolute value of f of x dx. And if you're just looking at net area or just area, then it's simply going to be the integral from a to b of f of x dx. So the absolute value guarantees you total area under a curve. And so I'm going to take the absolute value of a negative x squared plus 6x minus 5 dx. Okay, and I'm going to first show you how to do this on your calculator. And so I'm going to grab my calculator. And I'm going to go over here. And I'm going to delete this one, I guess. I don't really need that. And I'm going to draw this one. And so you could see everything's above the x-axis, and so all my area is above the x-axis, so it's going to be positive. And on this calculator, I can go to gsolve, and then go to integral, and I'm going to say go from 0, that's my lower bound, that's my a, into 6, my upper bound, and it's going to compute my area. It tells my area is 15.3 repeating, or 15 1/3. So that gives me, when I do all my work, that's what I should get as an answer. And so the first thing I'm going to do is I'm going to let that negative x squared plus 6x minus 5 equal 0, and I'm going to find the intercepts of this quadratic. Well, I'm going to divide everything by -1 and get x squared minus 6x plus 5 equals 0, because for me it's easier to factor. And I'm going to factor this to x minus 1 and x minus 5. So my intercepts are x equals 1 or x equals 5. And you saw that from the graph. Those are the two parts it was touching on the graph. So that means I'm going to integrate 0, that was my initial a to 1, and if I put 0 in this equation, I get a -5. So I know from 0 to 1 I have negative values, so I'm going to take the opposite of those y values, or the opposite of a negative x squared plus 6x minus 5 dx. And then I'm going to add to it, I'm going to integrate from 1 to 5, and that's the portion that's above that graph. I could put 2 in here, and I'd have 4 plus 12 minus 5, and that's obviously a positive number. So I'm going to have a minus x squared plus 6x minus 5 dx. And then again, I'm going to go integrate from 5 to 6, from that intersection point to my end point of the opposite, because if I put 6 in there also I get a negative value. So I know it's below the x-axis. So I'm going to multiply it by a negative. And when I distribute, I'm going to get of x squared minus 6x plus 5 dx plus 1 to 5 of a negative x squared plus 6x minus 5 dx, and distribute right here. x squared minus 6x plus 5 dx. Alright, so now I'm going to integrate, and the antiderivative of this is 1/3 x cubed minus 3x squared plus 5x, 0, 1, plus minus 1/3 x cubed plus 3x squared minus 5x, 5, plus 1/3 x squared minus 6x plus 5, integrating from 5, 6. Alright. So I'm going to put 1 in here, and I'm hoping that, you see, when I put 0 in here, I'm going to get 0. So I'm going to have whatever my value is when I get 1 minus 0, it's going to be just that value. So I'm going to have 1/3 times 1 cubed minus 3 times 1 squared plus 5. I'm going to forget the 0. And I'm going to have 1/3 minus 3 plus 5, and that's going to give me, let's see, 2 1/3, and 2 1/3 is 7/3, so I'm going to have 7/3 of this integral right here, and I'm going to save that, and I'm going to do this one, and I know I'm going to add them. So this is going to give me a negative 1/3 times 125, that's what 5 cubed is, plus 3 times 25 minus 5 times 5 minus, and I'm going to put the 1 in there, and I'm going to have a negative 1/3 plus 3 minus 5. Okay, that's what I get when I put the 1 in there. And I'm going to have a negative 125 over 3. This is 75. 75 minus 25 is 50. And 50 is the same as 150 over 3. So I did a couple of things there in my head. And over here, minus, I'm going to get a negative 2. I'll get a negative 2 1/3, so I'll get a negative 7/3 here. So if I add these two, I get 25/3 plus 7/3. So I get 32/3. That's what I get in that integral. So I'm going to circle that because I'm going to add these three integrals at the end. Now I'm going to do this particular one. I'm going to get 1/3 times 6. This should be cubed, by the way. Oops, no. Yes, this should be 1/3 x cubed, and this should be 3x squared, and this should be 5x. I'm sorry about that. And so I'm going to have 1/3 times 6 cubed minus 3 times 6 squared plus 5 times 6 minus, over here I'm going to have 1/3 times 5 cubed minus 3 times 5 squared plus 5 times 5. And so this is going to be 1/3 times 216 minus 3 times 36, which is 108, plus 30. Minus, over here I have 125 over 3. And this is minus 75 plus 25, so that's going to be a minus 50, or 150 over 3. So this is going to be 72 minus 108 plus 30. And this is going to be a negative 25 over 3. And this is 72 minus 108 is a negative 36. And negative 36 plus 30 is a negative 6. So I have negative 6 plus, let's see, 25 over 3. And that gives me a negative 18 over 3 plus 25 over 3. And that gives me 7/3. So I'm going to circle that. So now I have 7/3 plus 32/3 plus 7/3 gives me 46/3, which is 15 1/3, and that's the total area underneath that curve.